Hi folks, Mr. Bob here, idea guy. And are you tired of tokenization? Do you think artificial intelligence is cool, but can I interest you in some artificial life? So life to me, it metabolizes energy, it grows, it reproduces, it organizes the cells, and those cells are built out of individual organelles, which are distinct but interdependent little. So we all know and love Solidity. It manages capital, it accumulates data, it's organizing into smart contracts that are built out of functions. Functions can be interoperable across contracts, but does it replicate? And the biggest problem we have is agency, because nothing happens outside of a human-signed transaction. My objective in this project is to build a cell-inspired, multi-contract, living organism using Solidity. And why am I doing this? Well, it's to create an ever-evolving ecosystem of anti-fragile microfinancial vehicles. And I'll let the implications haunt you in your dreams. So the core of the cell is a nucleus, and it defines membership in the cell and the identity of the cell and what makes up that individual. As you can see in my design, it's mostly just a list of links to all the other organelles. So I wanted to build a leucoplast next because I'm forward thinking. I'm thinking about cell replication, and one of the determining factors of if a cell should replicate is, do we have enough gas on hand? That has to be a centralized contract that accumulates the base tokens and gas for the whole cellular apparatus. It also keeps transactions emanating from outside the cell from withdrawing the energy from the cell, and makes it available to all of the organelles that have membership in the cell. Can we replicate the cell? Chloroplast execute the cell replication process. It will deploy a new nucleus and then go through the list of all of the organelles that are members of the cell, flag what replicatable, deploy a new copy, and then hook it up to the new nucleus, or whether it's not replicatable and it's one single organelle, just the link to that organelle should be copied into the new. It also needs to talk to the leucoplast to see, hey, do I have enough gas to execute on this transaction? And after it finishes all that, it's going to go into chloroplast and take the remaining balance, split it in half, and shove half of it into the new chloroplast on the new cell. Future development would be the mitochondria that specializes in absorbing capital and use any DeFi strategy, different mitochondria models for each one of these strategies. Cellular Autonoma are going to have to live symbiotically with humans in order to get the humans to sign transactions that these cells need to operate, offering incentives to humans to sign transactions. So each cell will have its own, essentially, marketing department way down the line. So what if we write a new version of the nucleus or a new version of the mitochondria? How do we inject that into existing cells? I'm using AI and we developed organelle to test core feasibility of cloning. As you can see in my test scripts, I've got the nucleus built and all of its behavior tests running, lucioplast running, and I have a basic chloroplast actually working that interacts with the other two. Chloroplast is stubbed in. It's not really replicating contracts. The next step is going to be to bring in the Open Zeppelin clone library and see if we can use that. Each organelle chloroplast would manage that process. The first generation is going to have to be intelligently designed. Once the designs reach critical diversity, then we can engage in evolutionary reproduction. So what I'm hoping for is an emergent multicellular. So in conclusion, I'm exploring paradigms that are beyond tokenization with regards to artificial life. Solidity can do so much more in using some new computer paradigms. And I hope someday that this will be developed enough that we can have our little Wuhan moment and release it on the world. Until then, be seeing you.